Welcome to week 6, right? Quick announcement. If you check on Blackboard, you have homework 2, right? And for this homework, you can keep your peer from the previous homework, or you can work individually. And the due date is 24th. And again, Dr. Jamshidi giving a bonus point if you repeat the following homework questions and do it in the robotic toolbox, which is 25 points. And again, the due date is 24th. Alright. And everybody is happy with project proposal grades? Any questions? Alright, let's start. Week 6, we're gonna talking about the robotic and vision toolboxes that you supposed to follow up with your parallel to your textbook. And the outline is, we will start with a short introduction. Then talk about the linear algebra. I know all of you know, right? And then a little bit systems and control theory, and you're good on that too as well, right? And installation of robotic and vision toolboxes. Yeah, by the way, we have different versions for robotic toolbox and vision toolbox, right? You already know, right? If you click on the link on the textbook, you will see the robotic toolbox. We have version 9.9 and 9.10. Then there is some conflict between the vision toolbox. If you work on 9.9 and doing something based on Simulink and try to visualize your results, sometimes you can get error. And for example, the parameter or the object or the function doesn't execute by MATLAB. So in those cases, you have to switch the toolbox. You have to go to the previous version, 9.9, and basically adding or excluding from MATLAB workstation, your path. Then we will talk about a summary from robotic toolboxes for commands, functions, and few textbook demonstrations and questions. Alright. What is robot? Remember the first day in the ACE lab, we were asking you what is robot? Especially it's a joke from Dr. Benavides. What is robot?
Goal-oriented machine.
Goal-oriented machine, yes. If you look at your textbook, actually Dr. Koch giving a good definition. A machine that sends, acts based on an ultimate goal. And it repeats those functions, right? Okay. The origin is a Czech, actually in Czech language. It's robota, which is actually a labor, forced labor. Okay. And then from robotnik, the robot is workman. And the Karel Čapek, a Czech playwright, put this definition, the robot, in his play, the Rossum's Universal Robots, 1923. And okay, for the scientist engineering aspect, the definition will be an automatic device that performs functions to mimic human beings, right? Or more enhanced could be a robot is a reprogrammable, multifunctional manipulator designed to move materials. Mostly this definition actually includes the industrial robots, right? The multifunctional manipulator designed to move materials, parts, tools, or specialized devices, the end effectors, through variable programmed motion for the performance of a variety of tasks. Alright. This is my definition from my qualifying exam. Okay, the robot is an electromechanical machine that aims to achieve predefined tasks and future tasks from the past experiences, controlled by an onboard computer with a complex computer program, or remotely control from another agent, the cooperative control, right? With or without a wire connection. So, if you're working on underwater robotics, you should have a wire connection, right? Because you have to supply power. And meanwhile, you're communicating with robot. Or if you're working on a Land Rover, the communication should be wirelessly, and you have to deal with your power source, right? All right. But not everything is robot. For example, dishwasher, washing machine. Is it a robot? Yeah, you can implement artificial intelligence, right? And they sense the weight of they call it high efficiency washing machine, right? They can sense the weight of the load, and based on that load, they use less or more amount of water. But still, there are some things that the machine should fulfill to be a robot. For example, sensing and perception, gathering data from its work environment, right? Carry out different tasks. Washing machine, you just wash your clothes. Locomotion or manipulation, do something physical. And it should be reprogrammable. The washing machine, for example, is closed bug, right? We cannot do. You can reprogram based on pre-installed programs, right? And it should be or must be functioning autonomously and interact with human beings. So you have a robot. Okay, why do we use robots? We use them mostly in dangerous, dirty, and difficult work environments, such as nuclear power plant, to load or change the nuclear cores, right, the rods. Difficult, dangerous workstation, for example, a EOD Land Rover dealing with bombs, Scott robots, right? Then they should carry some of those tasks, such as automation. It should be assist to human being or another robot, and should be autonomous. Okay, some numbers. Industrial robots mostly use 70% welding and painting, and which reminds you what kind of industrial plant? Automobile industry, right? Welding and painting. And if you think about a robot, the first thing will be appear in your mind, the manipulator, right? So think about automobile industry, a factory. We just have actually manipulators, robotic arms. They're welding and painting, carrying the automobile frames, the car frames, the bodies. And 20% pick and place, Amazon warehouses. And 10% others, such as Land Rovers, Mass Rovers, humanoid robots, and some quality assurance robots. They look in nanoscale, like 1/100 of millimeter. They look, if there is a mistake on the product, they just replace it, right? Okay, and we mostly do research on robotics in manipulator control, end effector design, visual and force feedback, and flexible automation. Okay, the purpose is increased product quality. As I say, nanoscale quality assurances on massive production actually. Increase efficiency. They never get tired, right? Need no vacation. And what do you think? Do you think the robots will replace the human employers? What do you think? It seems and it looks like that way in automobile industry, right? But honestly, so what?
Well, it can be replaced, but it cannot be replaced fully.
Exactly. I mean, so don't worry. Keep studying. You will get it. Don't worry. Because, for instance, just if you're talking about the welding manipulators in auto industry, you at least need 4 engineers and technicians for taking care of one manipulator. Because those manipulators also communicating with each other, right? Which means wiring. They need power, and they has to be reprogrammable, right? If you change the robots, manipulators work environment, you have to reprogram, recalculate everything, right? Remember those parameters. They come default, right? But if you change the robot work environment, you have to change those parameters and reprogram everything. And what else? If you talk about again the nuclear power plant, we don't want to put someone in that place to change the nuclear core, right? Yeah, because why? Most probably it will be really hot, that environment, and radioactivity. Okay. So they increase safety. Meanwhile, they also reduce cost. They reduce manufacturing lead time. You have to be the first in the market. That's why Apple and Samsung competing, right? They have to be the first. And increase productivity. They don't get tired. They just keep producing. Okay. Revisiting linear algebra. And you should already know once you see 2x1 plus x2 equals to 0 and x1 minus x2 equals to 1. This is a linear system. And how can you solve this? How can you find x1 and x2? Yes. That's what I told our visitors during the outreach events. One problem has one unique answer, but you can reach that answer in multiple paths. You can follow different ways, right? So, for example, for this question, it says 2x1 plus x2 equals to 0 and x1 minus x2 equals to 1. So, one may say, okay, just add them up together. So I have 3x1 plus 0, right, equals to 1. And x1 equals to 1 over 3. And x2 equals to, it should be minus 2 over 3, right? Yeah. Or someone can say a different way, and I know something called Kramer method or something. So what you can do, just 2x1 plus x2 equals to 0. Then I just double this, 2x1 minus 2x2 equals to 2. So in this case, just add them up. Minus, okay. And 3x2 equals to 2, and x2 equals to 2 over 3. And if you take the minus, this should be minus. Alright, this is your x2. And also, since we already took the linear systems and control, we also know something like, okay, I have just two variables, and I have 2, 1, right? There is a 1. 1 minus 1. Okay, I have x1, x2, and this equals to 0 and 1. Does it ring a bell? Yeah, homework 1, right? Okay, we're coming through that. And so we just have a matrix, right? A bunch of real numbers, coefficients, and if I have this A, matrix A, there is X equals to B, for example. Alright. What else? The next is, a matrix is simply a rectangular array of real numbers. An m by n matrix is an array having m rows and n columns. And we also know transpose of A A dot, if you use MATLAB or any scientific programming editors or toolboxes, you should know A dot or A squared is transpose. And also we have inverse, right? If I have 3 by 4 matrix, how can I find, or in general, how can I find the inverse of a matrix? I know this, right? I have A, and if there exists an inverse of A matrix, the product of those two should be identity, right? Okay, so you also have to calculate the determine and put on operation. Alright, for example, matrix addition and multiplication, a product, matrix product. I have A and B matrices, then I know how to add them up, element to element. So A plus B should be A11 plus B11, then A12 plus B12, then so forth, and so on. But if I multiply or get a double of A, I just calculate 2 times of each element of A, right? What about A times B? A product B. Can you tell me the dimension of A? 3 by 3? 3 by 4? What about B? 3 by 4, right? Let's make it like this. So, can I make A times B, multiply B? Why? If you have MATLAB with your laptop, just open MATLAB. So, the inner dimensions should be same. So, if you product 2 matrices or more, these inner dimensions should be the same. What about A squared? A is 3 by 4. Okay. What about A squared? Which means A multiply A. So again, we cannot do that operation because what? The inner dimensions are not the same. They should be the same. But what about A dot multiply A in MATLAB? The dot operation. Exactly, it's pointwise element. So if I have A squared and asking by A squared, if I say A dot multiply A, I have an answer. Each element which is here should be what? 1, 0, 0, 4, 1, 0, 1, 0, 9, and goes that way. And also in MATLAB script, you can say A dot power 2. Right? Okay. Here we go. How can you enter a matrix in MATLAB? You already know. The brackets, rows follows, then semicolon, next row, semicolon, next row, so forth and so on. And if you put on your workstation the command line, if you use the dot operator, you can actually make this A times B, A dot multiply B, you will have an answer. If you don't use pointwise operator, you will not. Okay, based on these introductions, let us define the product AX M by N matrix with a column vector X. Okay? Because what? I say Rn. So X should be a column vector. So I have
an A matrix m by n, and I have one x from Rn. So x should be n, right? Because I have it here. So x1, x2, xn.
Which is something like this. And voila, we have Ax equals to B. We have our system. And you already know how to make this multiplication. A11, x1, you're basically scanning the first row of A with x vector, second row x vector, and each goes but the row corresponding to the n. And you have B, which is let's say B1, Bn. Alright, state space equation or representation. And you're really familiar with this because of your homework, first homework. Okay, in similar to this, I have AXT and BUT, which is input-output representation with system matrix or output matrix, right? A and B and C, D. Most of the time, if you have feedback, you have D, otherwise D could be 0. Okay, let's take a look at this example. I have fourth order a differential equation. For your homework it was second order, I guess, right? So it doesn't matter, third order, second order, fourth order. I pick this one deliberately because it's easy to show the process. So I have y dot 4 dot actually, the fourth order derivative is actually means 4 dots. It's easy to show, that's why. And the system is like this. Oh, you can see that. Okay. 4 dot plus A1 coefficient y3 dot plus A2 y2 dot plus A1 y dot plus A4 y dot equals to B0U, actually your control. Here, how can I define the state space equation? Simply, I'm giving another name for starting with the lowest order. Y equals to x1. And then I have what? Y dot, right? So, y dot equals to actually x1 dot. And I'm picking x1 dot. I don't want to deal with the derivative of x1. I'm just saying x2. Then I have y2 dot. Then which is actually x2 dot, right? See? Y dot, which is x2 dot. And I'm telling this x3. Then y3 dot equals to x3 dot, which is x4. Then after this, I'm just rewrite my equation here based on this new parameters, okay? Which is y4 dot equals to x4 dot, right? Which equals to minus a1 y3 dot, which is equals to x4 minus a3, oh wait, here,
x2 minus a2 x3 minus a1 x4 plus my control. Now it looks kind of confusing, right? But actually we are done. Here's the reason why we are done. Look at here. Oh, I'm just keep writing each element based on the other one. Same. x1 dot equals to y dot, x3 dot equals to y3 dot, and x2 dot, x4 dot. Now, since I have my x, which is x dot, which is x1 dot, x2 dot, x3 dot, x4 dot. Now, in this equation, this one, I'm just keep writing the same one. Their coefficients, which is equals to 0, 1, 0, 0. Here, 0, 1, 0, 0. Oh wait, I forgot to rewrite. Here, for x1, I just have x2. Zero, 1, and I have nothing. 0, 0. The second parameter I have for x2 dot, I'm looking to the x2 dot. I have just x3, right? 0, 0, 1, 0. Then y2 dot, which is y3 dot, which is x3 dot, and I just only have x4. 0, 0, 0, 1. And for the last one, x4 dot, I have just these, right? So, minus, oh, this should be 1. Oh, which one should be 1?
Should be A4, X1.
A1, x4, right? A1, x4, okay. 1, 2, 3.
Now it should be A4, X1.
A4, x1. So here I have minus A4, minus A3, minus A2, and minus A1. And here I have my x's plus, for u I have nothing, just b0, right? 0, 0, 0, b0. And u. So you have your state space representation. This is your A, the system matrix. This is your B. And for C, I have to write it y equals to 1, 0, 0, and x1, x2, x3, x4. And here my d is 0. All right. A is system matrix, B is control matrix, C is output, D feed forward. And if you have feedback, it's 0. In MATLAB, this is the script. System equals to SS ABCD. You know how to enter your ABCD matrices, right? Yeah. And if you're working on transfer function, right? If you have something like H, can you see here? Okay. If your H is, now couple of numbers here, couple of numbers here, so it will be what? The coefficients, which is zeros and poles. Those zeros and poles coefficients will be giving your A matrix, B matrix, and C matrices. Alright. And a pendulum example. It's too late, sorry. Okay, that was your motion equation, right? And here you can see I have ml theta 2 dot equals to minus mlg sinus theta t of t and minus kl theta of t dot. And you know the theta is the angle, the m is the mass of pendulum, g is gravitational acceleration, k is a friction coefficient, and l is the actually the radius of pendulum based on your center of gravity. Okay? I mean you can take off the L from the equation. That's why you have to take it into the center. And here my theta of t is x1. If I take its derivative, it should be my x2 of t, which is theta dot of t, right? And then if I take a derivative of x2, I have theta 2 dot. Now I just have to rewrite my state space equation. X dot equals to x1, x2 dots. And if you look at the coefficient in the last example, for x1 I just have x2. x1 equals to x2. And the rest of it will be giving x2 dot. And you have to linearize from here. Simply for small amount of theta, you can take the sinus theta equals to theta, right? And so forth, so on. Alright, let's take a break here.